Hello and welcome to Beyond the Gates. I'm Annette Kirkland. This season we're talking about today, tomorrow, always. We will highlight how ERDIC is delivering impactful solutions today, driving innovation for tomorrow, and prioritizing people always. From groundbreaking research to enduring partnerships, we explore the power of progress rooted in purpose. Today we are going to be discussing de-risking the future, smarter, safer military facilities. I'm going to be speaking with Madeline Shunk, and she is a research computer engineer with the ERDIC Construction Engineer Research Laboratory, otherwise known as SERL. Hello, good morning, Madeline.
Hello, good morning, Annette.
How are you?
I'm doing all right. How are you doing?
I'm doing great. Well, we're going to get started here, but we always like to start off with a really fun question. So the listeners get to learn about you. So can you tell me about yourself, your background, and your role at ERDIC?
For sure, yeah. So as you mentioned, I'm a computer engineer by training. So I graduated from the University of Illinois with a bachelor's in science of computer engineering in May of 22. So feels long ago, but actually wasn't all that long ago. I actually interned at SERL for a long time. I started in 2020 interning, so that lovely, completely remote interning expedition we all went on.
Right.
And then I stuck around post-COVID, and when I graduated, I joined our Building Energy Systems team here at SERL, which conveniently abbreviates to BEST. So I've been with them now for the last 3 years, which is wild. But they really have been the best. They've given me a lot of really great opportunities. I've been able to take on a lot of interesting tasks and responsibilities. And the most exciting of which is now I am the lead for our control system test lab here at SERL, which is, kind of my baby that I'm excitedly raising. So that's kind of what's going on with me now and how long I've been, kind of around and about in ERDIC.
Well, that's a great story. So then you've already kind of hit on what we're going to talk about more. So to start off, what are facility-related control systems, or FRCS, and why do they matter to the military?
Yeah, so FRCS actually is a term that originated out of a SERL effort. So we've had a little bit of a hand in kind of shaping how these systems are talked about, not just in the military, but also in industry as well. So it is an official military definition that's on the books as part of our Unified Facilities Criteria, or our DoD Building Code, as you can think of it. FRCS are a subset of control systems, or operational technology is the other really popular term you'll hear a lot about in industry. And FRCS are used to control and monitor equipment and systems related to military real property. So a lot of fun jargon there, but essentially it's the systems that run, electrical and mechanical systems that run and operate, the buildings and infrastructure that the military owns, and keeps on our books.
Perfect.
This includes things like building control or utility control, electronic security systems, and fire and life safety. So that's kind of all the things that fall under this umbrella. There's a couple others too that are smaller, but those are kind of the ones that everybody's most familiar with.
Well, and super important.
Oh, yeah, absolutely. So obviously, we have a lot of real property in the military, and those military real property has a lot of these systems. So we have thousands of FRCS across our military installations, and they're really vital to day-to-day operations and to the overall mission.
So as we're talking about, the military has a ton of buildings to manage, right? So how do these systems actually help keep them running smoothly?
That is a great question.
Thank you. I work hard on these.
They are excellent. They're so good. So control systems don't necessarily kind of make those mechanical and electrical systems run, right? Like they don't always be the ones flipping the on switch, but they do make them run effectively. So while systems kind of like your home HVAC, which would fall under that, sphere of FRCS, are pretty straightforward, right? You've got a thermostat and a single unit in your home. An office building has a lot more going on, right? Mm-hmm. Everybody's office has their own unit that's feeding it, and they've got, they've each got their own thermostat, and they've each got their own lighting systems and all that kind of stuff going on. So these control systems have to monitor multiple spaces and are ideally adjusting for things like occupancy and occupant comfort, right? So
Right.
for the military even, we've got one building that's complicated, but for the military, we've got a ton of buildings across an entire installation that are all trying to do this. And ideally are all coordinating so we can make the best use of the energy that we're using, right?
Right.
Because these control systems don't just dictate how an installation, cools its spaces and lights its rooms, but how it uses the energy that we bring onto the installation. And energy is dollars, so these control systems dictate so much of how the military spends money on a day-to-day basis. I kind of like to use the analogy, because analogies are the best way I find to explain these things that feel so distant.
Mm-hmm.
Control systems are kind of like the conductor in an orchestra,
Okay.
right? The players can probably play without them, and they might be able to roughly play together in something that resembles music, but they really need a conductor to put on a good show because there's so many of them and there's so much going on.
Great analogy. When we hear the term de-risking, can you break that down for us in plain language?
Yeah, absolutely. So this term I actually borrow from our colleagues over at the Department of Energy who are working on some current efforts with that have the title, de-risking FRCS. So it actually refers to a concept a lot of us in research are very, very familiar with, where you go and you take this brand new technology that you're so excited about out for a field demo that cost most of the cost of your project, and you bring it out there and you encounter some major unanticipated hurdle that ultimately kills it altogether, and you don't get to do this thing you were so excited about. We don't get to use this new cool technology because something happened in the military context that we just weren't expecting. It's a very common thing in research.
Mm-hmm.
De-risking refers to kind of conducting lab-level testing to try and identify and remediate those hurdles before we encounter them in the field. It's something that a lot of us kind of do for a lot of different things already, but there are some fields, particularly like control systems, where we're lacking a lot of the support for that type of approach. So our ultimate goal right now that we're working toward is to establish for control systems, us and our partners work together to agree on a standard way to approach this for military efforts.
So it's like safeguarding.
Yeah, absolutely.
Okay, awesome. So now let's dive into what is the Control System Test Lab, or CSTL, and what kind of work goes on there?
Yeah, so the best kind of work goes on there. So our Control System Test Lab, CSTL, or the CASTLE, if you would prefer. Which
I like that one.
Brand for
Yes.
these days, right?
Yes.
So it's a lab specifically meant for this de-risking of FRCS work. The goal of the CASTLE is to test new control system technologies for functionality, interoperability, usability, and cybersecurity. So the military environment has a lot of unique challenges and requirements in the field of control systems, like it does in a lot of other things. And so the Control System Test Lab can emulate this military environment in the control system space to make sure that installations are getting the best and most suitable solutions for that unique environment. And right now we're working alongside with others in the research community to pull together methods from across various efforts to deliver this holistic testing to our military customers.
Okay. So at the end of the day, though, how does this effort save the military time, money, and maybe even a few headaches with new technology?
Yeah. So kind of as I mentioned before, when we were talking a little bit about the de-risking topic, field demonstrations are a big lift, right? They cost money, they take time, and a lot of effort from both our researchers and our on-site staff. So de-risking beforehand can help to ensure that we deliver on that investment. There are also a lot of issues that can arise after demo that you may not catch in that field demonstration because it is somewhat of a snapshot of performance in a lot of ways. So that's why the holistic assessment is so important. So a new technology may function beautifully in our field demo. We're so excited, it's gone so well, but what if it's not up to snuff for cybersecurity and the installation can't get it to stay connected because it doesn't meet our cybersecurity standards? Or what if the maintenance burden is too hefty and so our installation staff abandon the technology in place? And then what if it's not compatible with the mosaic of control systems we have out in the field, and so it ends up being like a single building or a single system solution, right? So these are the issues that we're trying to alleviate in the castle before we invest in a field demo. And that back and forth also allows the technology developers that opportunity to adapt their technology to military environments earlier in the process, right? It allows that kind of back and forth, and it makes sure that when they do get to go to a field demo, it's as successful as it can be, and so then we can move out and get this new technology in the hands of people who need it. And this also applies outside of like the more research demo context. The CSTL also can support the installation of commercial off-the-shelf technology in normal construction, right? Mm-hmm. New technology has hit the shelves. People are looking at installing it. How do we know that it's going to be a good fit for our military environment? So the castle can support in that way as well.
Okay. So I know ERDIC isn't doing this alone. So who are some of the partners working alongside you on this effort?
Yeah, so we certainly couldn't do this alone, and I know you said, ERDIC isn't doing it alone, but I do kind of real quick want to give a shout out to one of the castle's long-term partners from within ERDIC, the folks over at the Information Technology Lab, or ITL, particularly their Cybersecurity Engineering and Analysis branch. We've worked really closely with them now for a number of years, and that's been a really great partnership within ERDIC. Outside of ERDIC, we've had the opportunity to work really closely with the National Renewable Energy Lab, or NREL, and then a team from the Navy Facilities Command's Expeditionary Warfare Center, or NAVFAC-EXWC. We also have a lot of ongoing efforts we're pursuing with MIT and Lincoln Laboratories, as well as Idaho National Labs.
Well, perfect. So I love to hear when labs are working together too. That teamwork makes the dream work scenario.
Absolutely.
So when you put these systems to the test, what are you really looking for? Things like energy saving, security, performance?
So yes, and yes.
Okay. All right, we figured it out.
Absolutely, right? We've solved all the world's problems. We're good to go. Everybody can go on. So the truth is that it depends, of course. So if a technology should or can affect how the building uses energy, then we want to either kind of verify claims of energy savings that are being made or ensure that the technology doesn't degrade operations, right? Like maybe it is proposing to do kind of something else in the system, but we also want to make sure it doesn't affect kind of, that bottom line of how much we're spending on energy.
Right.
And mission always comes first, right? And in all of our work, that's a constant. And so a big part of that functionality testing is how will the solution affect the mission? So when we talk about functionality as part of what we do in the CSTL, that's kind of our big focus, right? Making sure we don't disrupt operations in any big way and making sure that we are adding to operations in really big ways. We also want to make sure that the solution will work with our current inventory of control systems, regardless of age or vendor, and will work for our current staff at our installations. So military installations are built building by building over long periods of time, so no two buildings are identical, and we see a lot of variety in control system hardware and software across an installation, sometimes even within a single building. So these solutions need to work with as much of our assortment as possible, and they also can't be a burden to our DPW staff that are so diligently maintaining these systems, right? Our installation DPWs wear a lot of hats. They do everything from changing air filters to filling potholes to doing energy audits to reconfiguring control systems. They're doing so much, so there's only so much room for added complexity when it comes to introducing new technology to an installation. And then for the cyber piece of things, we want to make sure that a solution doesn't introduce any unforeseen vulnerabilities. We're also seeing a lot of cyber-specific solutions these days, and we want to ensure that those not only provide the cybersecurity that they promise to our FRCS, but also that they don't compromise the mission in other ways.
Okay, so we dove into this next question. So, it's always cybersecurity with everything. It's always going to come up. So, and you're talking about how it's important. It's important. Cybersecurity is important when we're talking about these control systems. Anything else you want to add about that in military buildings?
For sure, yeah. So I kind of laugh a little bit, but control system cybersecurity is a lot more complex and nuanced, I think, than a lot of people think. Control system cyber is kind of my main area of expertise. So you'd think that I wax poetic. It's the most important thing any of us will ever do, right? But my feelings about it are actually really complex and nuanced, particularly in the military context, right? So when you talk about is cybersecurity important, it depends. What do you mean by cybersecurity? What do you mean by important? And what type of building are we talking about, right? when we talk about cyber, a lot of us think more of the information technology systems we're really familiar with, right? So if you work for USACE, you have your ACID IT network. If you work for ERDIC, you also have our research network, the RDE. And those systems, like all other IT systems, trade in information. So confidentiality and integrity of that information are traditionally very paramount when we talk about cybersecurity. You would rather have your credit card declined than have your credit card number stolen, right? One of those hits your bank account a lot worse.
Right.
So you care about the confidentiality of that information. But when we talk about control systems, they don't deal in information the same way. They deal with the real world. They're interacting with real world systems. They're interacting in real time. So what we care about with those systems is availability. So it really turns our traditional concept of cyber up on its head, where we care a lot more that the lights are on.
Right.
Than we care about if you know the lights are on, right?
Right.
So that kind of changes the perspective when we talk about cyber so much in these contexts. And then to add that additional layer that military contexts always add, we care, is this building critical or non-critical? And is that criticality dependent on the control system that we're talking about? So military obviously has critical and non-critical facilities, and we also have a limited number of cyber resources, whether that's dollars, time, personnel, all of those things. We're only working with so much. So for our critical facilities that depend on their control systems, cybersecurity is very, very important. It needs adequate money, it needs adequate people, it needs adequate time for us to invest in it and make sure it's as secure as it can be, so that we know that our mission is secure, that we can meet the mission, and that no cyber adversaries will come in and degrade our ability to do that. But we also have a lot of facilities like barracks and office buildings and mess halls, right? Where is the heating and air conditioning of that system, is the cyber really as important in terms of how much money we spend on it? Maybe not, right? Security is always important in a certain context. But when we translate that to the practical, the nickels and dimes, the personnel we dedicate to it, not only is cybersecurity of lower importance for some systems, it needs to be, because we have to strike this balance of making sure we're investing our resources in the systems where it really matters, and that we're reaching kind of an acceptable low casual investment in some of those systems where we can afford to eat a little bit more of that risk. And that's kind of what I think makes our research so important, and the research we do in the castle so important, is that's a really difficult thing to kind of navigate. It's a hard thing to prioritize when you're looking across such a large portfolio. And so the expertise that we provide helps us ensure that we're making the best use of our resources so that we can still effectively meet the mission without any of those major cyber concerns.
So important, so important. So what does all of this mean for the soldiers and families who live and work on military bases every day?
Yeah, so I touched on it a little bit, but control systems often kind of operate in the shadows, more or less. Most people aren't thinking about, the systems in their walls and their ceilings that keep their office comfortable or turn the lights on and off when they enter or leave a room. But those systems are so important to quality of life, to energy spending, and ultimately to the mission. So there are server rooms that help coordinate military operations that are cooled by HVAC so they can keep running. Installation daycares where our soldiers' children are looked after are monitored and protected by our electronic security systems. And then, that electric bill we all dread to pay is monitored by a meter, which does also fall under FRCS. So these control systems touch every part of the soldier and their families' lives and work to serve them and their families, right? These systems are in a lot of ways systems of service. And so it's really important that they work well and that they operate securely.
Perfect. So, all right. So looking ahead with your crystal ball, how do you see this changing the way military buildings are run, in the future?
Yeah. So I see the castle as a key technology transfer pathway. So there's a lot of really amazing work in the world of control systems, whether it's looking at energy savings or workflow improvement or cybersecurity that's being done by labs and by companies alike. But for a lot of them, the deployment at the field level is just out of reach, right? There's some barrier, whether it's being able to negotiate the military cyber processes, whether it's getting bases on board with the new technology, whether it's getting test results that they need to prove XYZ thing by a reputable source, right? There's some stuff in the way, right?
Right.
And the castle can provide kind of that much needed leg up to kind of get over that hurdle, get over that barrier, and really get into the field. So we've identified a lot of major kind of milestones that the military is working toward where this castle can provide a lot of key support, particularly in increased system and data integration, improved fault detection and remediation, and a higher level of system security, where we can kind of support a lot of those solutions getting into the field.
Right. Okay. So in closing, are there any key takeaways you'd like our listeners to understand about this research?
Yeah, so we've talked about a lot of different stuff, but kind of my key thing is what we just touched on a little bit of that tech transfer, right? So this is either something that researchers can forget about, or it's something that'll keep us up at night. Everybody's heard about the tech valley of death and all of these things. It's one of the kind of constant struggles of new technology and of innovation, right? And the focus of this effort is to get our research, to get ERDIC's research, to get research from various partners in the field into the hands of people at military installations to use it, so that we're using the best that they have to offer, and that those solutions are helping us be the best that we can be, right? The Army, you be all you can be. So we want to really be able to do that. It's a small field where we're tackling it, but it is one that's so important and touches so many spaces of the soldier's life and of the way that our installations run. So being able to kind of hopefully springboard some of this new technology into the field is a really big part of this effort.
Perfect. And thank you for what you do for the nation. Appreciate you. So, and thank you for being on the show today, Madeline. And it's been a pleasure.
Thank you so much for having me.
Absolutely. And thank you for listening, and come back at you next week. Thank you for listening to Beyond the Gates.